Good afternoon. I'd like to invite you to see our last presentation of today, Industrial Interoperability with OPC UA, including SPE, APL, TSN, and 5G. Our speaker is Paul Hunkar, who is the Director of Compliance for OPC Foundation.
Okay. Thank you very much. I will go through and give you a little more of an introduction for me. I'm a consultant. I work for the OPC Foundation, and I also work for OPC. And I spend a lot of my time doing OPC. And we're talking all aspects of OPC. So I'm director of certification for them. I run their test labs. But I also am on the technical advisory council. So I run the standards. I'm editor for several specs. So I'm pretty much an expert at OPC. So let's go through this a little bit. I think there's my bio and abstract for presentation. First, I'm going to talk a little bit about the OPC Foundation itself, right? So the OPC Foundation is a nonprofit international organization. We specialize in standards. We have over 1,000 companies as members, so it's a very large organization. We specialize in secure, reliable communications, vendor independent, platform independent, and it's interoperable from the sensor up to the cloud, and it goes beyond even. We have a pretty good profile of having a nice IP policy to make sure that you can adopt it. Everything we do is open source. Specs are publicly available. Once they're released, anybody can have it. Reason people join? They want to work on the specs. So that's the benefit of being a member. You work on stuff before it gets released, right? And we provide certification for systems, and I'm the director of that. Again, a membership gets you a discount on the certification costs. So let's talk on a little bit about what OPC UA really is. It's not just a protocol. There's way more to it. It's a collection of technologies. It's secure in design. So it's security baked into it from the beginning. It's standardized information modeling. So it'll run through the whole system. It runs in sensor, it runs up in the cloud environments. It supports a whole lot of protocols. So underlying protocols can be APL, SPE, 5G, TSN, and I'll talk about some of those, but it's also TSN and UDP, TCP. So it's got a wide range of underlying protocols that we make use of, right? We also have information modeling capabilities, and information modeling in particular allows other organizations to help build companion specs, we call them, which is models there for their critical industry. So if you're in robotics, there's a spec for robotics. If you're into, pretty much anything, you'll be able to find it. There's one for tobacco machines, one for coffee vending machines now. So a lot of people use OPC UA because of the intrinsic security limit. So you can transmit the data around securely, and you can transmit it as a log. Basically, this is sort of a clue on the fact that we have 170 plus companion standards. A lot of people consider us more the collaboration organization because we don't write those companion standards. We get with other organizations to do it. And there are a lot of organizations that want to work on writing standards with us. All right, let's talk a little bit more about some of the stuff we do as an organization. We have a new initiative, or it's not so new, it's been around for a little while, but it's about field leveling. So we've always been able to run OPC UA down in a controller, but now we're enhancing that, improving upon it with the UA effects work. I'm one of the developers of this. I'm one of the editors for different aspects of this spec. But in particular, what this is focusing on is controller to controller and controller to device communications. So between two controllers, between controllers and devices. It will add also 5G support. So it's part of what falls into this group. And APL falls into this group and other things that are down lower levels. So we support communications. Some of the key things here we do is it's dynamically created high-speed communication links between devices. So you have less engineering and easier engineering with this communications because it can be created dynamically. Let's go on a little bit and talk about, we're not always taking pictures, about all the stuff that's actually in here. We have working groups to create motion models and instrumentation models in IO. We have sort of a base component for the whole piece. It includes all the TSN settings and the APL settings. All APL is pretty straightforward. We also support it over 5G. So we can have the communications that doesn't have any wires effectively, right? So I can control my robot without a wire to it, which is really good if you've got a mobile robot in a or in a warehousing facility that needs to go around and pull things off shelves. 5G. And all of that can run over OPC UA and effects. We also have companion specs, standardized information models for these. The UAFX group is a subgroup of the standard of the OPC Foundation, but just a subgroup. They contribute extra money because we know that for field level communications, there's more certification work, more testing work. So the people that are members of that group pay some extra funds to let us go for the certification stuff, primarily, and some marketing. All of this in OPC UA, remember I talked about information models very briefly. It lets us expand the information models to let you have a base model that we built. But if a vendor has, hey, my device has a few extra features, it's really easy to extend the model to add your additional functionality that you might want. So that's the nature of OPC UA. That's sort of the base aspects of OPC UA. So let's talk a little bit about what UAFX does. It has information modeling built in, so it's a standardized model for the device-to-device communications. It also includes network models, so I can automatically configure networks. So I can set up the TSN network dynamically. In the world of controller, if you're on a TSN network, you can't just have two controllers. You have to configure the switches and the bridges so that they'll share the data at the right data rates and speed. And that's part of what FX does too. We also have offline engineering. This day and age, you want to be able to look at what your system's capable of offline. So we support a set of AML models that let us represent the devices in your engineering tools. So you can see an engineering tool what you have available and what the device is going to do. Now it's a busy slide, but we'll go on. So let's actually talk about what the pavilion's about a little bit. Ethernet APL. This is, in the previous presentations, you've heard about intrinsically safe. You've heard about power consumptions, power on the wire. I can go repeat all of that, right? This is all stuff that you do, but part of the key point is you can layer whatever protocol you want on top of this. So if you are a Profinet fan, you can run that as your ODA, Ethernet IP again, but you can also run OPC UA over it. That's the key part we do is OPC UA is a, standards-based protocol that's easier to adopt and use, and it runs over APL. We've tested it, we run it, works quite well. And I think the slide deck is not just my deck is the problem. The next topic we want to talk about a little bit is TSN. So time-sensitive networking. This is actually a very large group of IEEE standards that together let you transmit data, reserve bandwidth, guaranteed latency and delivery. So it depends on which ones you pick, but it allows you to guarantee that your two machines will always get data no matter what else is going on the wire, and the latency is correct. You get it within the time frames you're expecting. All of this is stuff that OPC UA can do, and it's supported natively in what we do. Where are we with the FX specs? We've released all the controller stuff. It's available already. It's published. You can download it from the spec, from the websites. We're working on some of the device models now. So the IO instrument sort of work. We have certification already for your earbuds. So if someone wants to go test their device, we can test it. Run certification for it. Device models are in progress. They're going to take a little while yet. Sometime early next year, we should have some previews of the device models out. And this is for, temperature sensors, pressure transmitters, I/O modules, and also motion. So there's a very large menu of motion devices that are being on. Let's go on a little bit about what I do for the foundation too. So we run certification, we support certification. There's Ethernet APL testing. Our labs can do the testing. So in the world of process industry and in manufacturing more so, you want products that have been tested because you don't want to have to be testing it at the factory or at the plant. You want to make sure that everything works or follows the standards, it runs correctly. So the foundation provides a certification program for OPC UA. We can also test Ethernet APL. So if you go back in the SPE build thing, you could talk to some of the vendors there, in particular the center there, you'll see test equipment. There's some standard test equipment out there for it. The foundation uses some of the same equipment for certification. We don't build equipment, we run the tests and make sure you get certified. Part of what we did with the APL environment too is we tried to ensure that whether you went to a Profinet lab or an ODB lab or an OPC lab, the testing that's common for APL is shared. So if we run the testing and you have a device that talks OPC UA and also Profinet, you can take it to the Profinet lab and just do the Profinet part of the testing. We don't have to test the APL piece again. So we'll share all the results between the labs. And that works the other way too. So it's right the Profinet first. We'll take the APL results they do. So the neat thing is it's simplifying the vendor's work for generating a certified product. And you do want to certify this stuff. It's too easy to make a mistake in what you're doing, and the labs will find all that for you. So we provide testing of the OPC pieces for the product too. And the APL devices are a little slower than some of our other devices, so we have to go tweak the testing some. Because I'm sorry, sometimes it takes a little too long and some of our test time now. But it's very entertaining. We've tested some devices. Other than adjusting some timing parameters for some of the tests, everything else works perfectly fine. So we had no problems certifying products and testing them. We haven't had a lot of APL devices, but we have run through some through the testing. They work quite well. So in general, it's a nice system that runs well. So we have a full certification program. We have test tools that you can audit and test yourself, downloaded from the foundation's website. It's free to members. If you're not a member, you can purchase it. It's not expensive, but the foundation doesn't make money under certification. We try to cover our costs with it. It'll test the UAFX stuff as well as just standard OPC UA functionality. We have a fully blown certification program. So the FX testing's been available since November, but the program itself has been around for general testing for a long time. We will certify your product and test all the interfaces, everything that you expose. So if your information model, or if you have a historian, or if you have alarm support, along with the communications, all that will get tested. We'll review it, make sure that your device is following the standard in all ways. We also have safety testing. This is still coming out, hasn't quite been released. It's because the safety testing has to be approved by a safety body. So TUV is still working on qualification for all of that. We're thinking that should happen soon, but it's not my call when it happens. So I think we got all the paperwork finally through. So hoping we'll get the safety going sometime before the end of the year. But safety certifications, and that's mandatory in most industries. You can't release a safety device unless it's been certified. Just sort of obvious, and many shows will bring a wall. This show we didn't. There's a booth over here for OPC that shows you hardware. So UAFX is not paper standard something. There's many implementations of it already. We'll have a wall that shows you interoperability and connections between them. And these are just some of the vendors. I don't think this is all. I think this is what last demo wall is about. And people get things on the wall by volunteering to donate one. I don't know. Mike is sitting here. He's North American head, and he may tell me more about who's on the wall, but that's Hanover's photograph. Okay. So that's what was shown in Hanover. But it's a list of hardware devices. And if you're from any of these companies, you may realize it, but there's plenty there. We also have a 5G test bed that we're working on that was also at Hanover, I believe. This is another picture of this. This is 5G based devices, if I understand right. I was in Hanover. I'm not an expert with the 5G stuff that they did there. But the key thing is it allows you to have existing communications over 5G, standardize the displays. So you got a bunch of devices providing them the same information, standardized information model. If you want more information on this, I can probably find you more information, but I'm probably not the one to ask about it. We have general collaboration with the 5G organization for test beds and to ensure that everything runs well. This is something that the UAFX subgroup or the FLC subgroup is working on. Again, I'm not overly active in here, but the key thing is it allows us to have applications over a 5G network intermixed with OPC UAFX. So some of the part of it's on a real network and allowed to wireless network. It allows some of the demos that they've had will allow you to show robots collaborating together. So the system again works. This isn't something that you just say we can do. We've seen demos and get that up and running in various locations. Let's see, we're doing all right on time. I'm probably almost a little quick, but the foundation, everything we do is public. These are a bunch of QR codes to brochures. If you want them, you can also go to the foundation's booth and see this. There's brochures of pretty much everything we do. So Ethernet IP stuff, the 5G stuff, brochures, just general publicity. We're a public organization, so everything's available. We have brochures that actually show you about other things like the cloud initiative that we have, which is standardizing information, comes up to the cloud. This has pretty much all of the big cloud vendors are involved in it. They love our information models, makes it really easy for them to absorb the data, standardized data. And they have a whole working group on how to coordinate and make sure that they can upload all the information models easily. The other key thing here, which is something that we talk about quite often, is there's a whole set of success stories. So these are places that are actually using OPC UA, plants that have the entire plant running using OPC UA. There's the one that I always like is the Airbus one in the bottom right corner. This is Airbus uses it to provide telemetry data back on things they shoot up into space. OPC UA is now in space sending symbols down to us, right? So it's an entertaining one to go look at. And there's a brochure that provides details on this. One of the other ones is Equinor. They have a oil and gas field that's all using OPC UA. If you want to hear in great detail about any of these, Mike will give you a long-winded discussion. I got to poke in Mike a little bit. He's written some of these user stories up. That's it. That's my last slide. I'm going to let you guys have questions if you want. And I'm more than willing to sit and talk about any subject you're interested in. Any question? Why?
Yes, and the key saying what rates these ingredients.
A lot of the latencies depends on what you're running, right? So what the hardware is and what the device is. I've seen implementations in the tens of microseconds, but I am not expert at that. It depends a lot of it. It's about the controller, the hardware, the network. So we're not restricted by the communications protocol. We're restricted by the hardware we have on the system. Really? All right. So the UDP communications is very small packets, so the packet size doesn't cause any issues. It's what the application is and what the hardware you have between your two endpoints. but it's in the microsecond range. That it's reading dedications. Other questions? I knew Mark would have questions. That's a freaking question. I have to think about that one almost. Yeah. I mean, so, OPC UA has a bunch of underlying technologies, right? So we have client server that runs over TCP. We have the UAFX stuff or pub sub that's running UDP. We can also run the pub sub stuff over MQTT. And some of what you would get for how you want to set up your UA system depends on what your client is doing and what you want to do with it. Right? So there are many cases where a client server is more than sufficient. Process client will getting updates every 1 second. I don't need any high-speed communications. If I'm at a manufacturing facility with a bunch of robots that I need microsecond communication between the robots, well, now you're looking at UDP sub communication. The big thing here, though, is the information model is the same in all of them, right? So it's the same OpenCRA server uptime. And it's just picking a different communications. Many of the devices you buy, you support the client server and the pub sub. So you don't have to even buy a different device. You'll just have to configure it differently, or depending on what you want. And not every vendor has all protocols, but most of them support the primary TCP and the complete stuff. So a lot depends on what you want to do. All right. More questions? Oh, come on. Only one question on?
Always.
Oh, what's coming up next? Yeah, from on the UAFX side, it's the device one. So the device stuff is coming in. There's a bunch. We're getting new companion standards at a rate that's almost 20 more. There's lots and lots of those coming out. So vertical industries and other places that want models, and so we don't write those. Other organizations put those together and just help them. There's a lot of those, but the big thing that the foundation is doing is probably the UAFX device models and device solutions. Yeah.
You had lower runs. I still, you went for keys or bring up or
Most of there is some prototype device, but we don't have a lot of release devices I've seen that. The device models are there, but they have been testing them and trying them. That's where the numbers I'm getting are from prototypes and proof of concept stuff that people are putting out. See how fast and so and the UAFX stuff makes it automated, simple way to set up connections. The pub suck piece has been around a while, so those are based on something that someone just put together. The pub sub spec's been released and people are using that. You have to manually set those connections up right now, so it'll work. When all the UAFX stuff becomes available, sets it up automatically. So that's really the big difference between the two. So the numbers won't change. The setup gets easier.
say.
I think you had a question over there. The initial previews for some of the CDB are supposed to come out 2026. So we should have a preview out in the first or second quarter for 2026. And that, like I said, that's a preview. It won't be the final releases. Releases should be, depends on how the preview goes. And it's not my call. I'm the person writing the specs. The steering committee decides to release them. So, any more questions?